Hello everybody. Purpose of this video is to get you up to speed on functions. This is the checklist for last week and this week. You can see that there's a link right here in number 8 that says functions. I'm going to click on that and that takes us to the free online textbook. And you'll notice right here it says encapsulating a series of operations. Basically, a function is just some code that you are giving a name. And of course, Python stores that code in memory somewhere. The name of a function is a variable. You will get that question, odds are, on an exam, possibly on the homework as well. Just know that the name of a function is a variable as well. It's just a variable that points to some code in memory somewhere. So I'm going to start Tani up and we'll create a couple functions. The idea here is to do something similar to what you have to do in Project 4. So that's the where we're headed with this. I haven't made these videos before for the Introduction to Programming class, not because I haven't wanted to. It's simply I haven't had software that would do what we needed to do. And I found some free software over the summer and have been piloting videos with the advanced Python class and pretty well got the bugs worked out of it. You can probably see that I'm using Linux. I started using Linux in 2007 when I taught a class at Catawba on how to do everything for free on a computer. And after that class, I never went back. I've got 28 Microsoft certifications, and I just found Linux to be so superior that I use it on my servers. I use it on my desktop computers. So anyway, let's start Tani up here, and we'll get started creating a function. Okay, so you start creating a function with the def keyword in Python. And so this says def is short for define function. And then the next thing that we do is we give it a name. So let's write a function to square 2. So we'll name the function square. Now the rules for creating a function in Python are you have to provide a name. It has to meet the requirements for variable names. You have to put 2 parentheses and then a colon. This is what's known as the function signature. Okay, we hit enter. You'll notice that Tani indents for us automatically. That is the way Python knows what is part of the function, is as long as we stay indented. As long as we stay indented, you can see I highlighted the 4 spaces that it does when you hit the tab key in Tani. As long as we stay indented, we're part of the function. When we outdent, we're no longer part of the function. Indentation is very, very important in Python. Indentation is the way that Python knows what's part of a loop. It's how Python knows what's part of an if statement. And you can't mix spaces and tabs. If you start using tabs, you have to keep using tabs. If you start using spaces, you have to keep using spaces. Now, Tani automatically uses spaces. Even if you hit the tab key, it converts it into 4 spaces. But if you go get some code off of the internet and paste it into one of your programs, it has to match. We're using 4 spaces. Whatever code you pasted in would have to be indented 4 spaces as well. It also would have to be indenting with the tab, with the spaces rather than the tab. Okay, so enough about that. Let's do this. Return 2 times 2. Okay, so this function is going to square 2. Now you notice I put a return here. That's another keyword in Python that causes this function's name right here, square, to take on whatever the value of this expression is. And 2 times 2 we know is going to be 4. So let's try to run this program and see what happens. And you'll notice that it doesn't do anything when we try to run it. Okay, so Tani's going to ask for us to save this. So let me save this. I'll just save it in my downloads folder and we'll call it square demo.py. Okay, so I'm going to hit the run button and you'll see that this doesn't do anything. Nothing came out down below, did it? That's because we created a function, and a function is just basically a blueprint for how something happens. We never ran this function. When this code was run, Python created a spot in memory for this code and it gave it this name, but it never actually ran the code. So if you want to run a function, you have to call the function. So this is the way we would call that function. You put the name of the function and 2 parentheses. That causes Python to go run the function. Now you'll also notice that I outdented, so I'm no longer part of the function. I'm outdented. Now, we're not going to see anything happen if we do this, because if we want to see something come out in the shell window down below here, we have to print it. So I'm going to wrap that call to the square function inside of the print function. So you'll notice that I have the curved brackets here. This curved bracket matches that one. Okay. And then I have the 2 curved brackets for square. And so now when I run this, we'll see the 4 print out down below. There's the 4. Okay, so we just called that function. Now, we have an old saying in programming, experience is what you get when you don't get what you want. So I've had some experience, and students have, with this in the past. Watch what happens if I do this. I just forgot to put the curved brackets or the parentheses on the end of my function name. If you do this, Python is going to tell you where that function is in memory, but it's not going to run it. Okay, so here goes doing our experience adventure here. We're wanting to run this function, but we forgot to put the parentheses on the end of the function name. So watch what happens when I run it now. What does it say? Function square at 0x7ff218a0b9d8. That is the memory location of where that function is stored in memory. So if you forget to put the parentheses on the end of your function call, this is our function call right here. If you forget to put these parentheses on it, Python thinks you just want to know where that function lives in memory. Okay, so I've fixed it again, so we'll see the 4 coming out. Okay, now this is not a real useful function right now, is it? It only squares the number 2. But if we wanted to have this function where we could pass something to it, when we define the function, if we put something inside the parentheses, if we put something inside these parentheses in this spot right here, it's called a formal parameter, and it becomes a local variable inside the function. So if I do this, num, this is going to create a local variable that is only alive inside of our indented code here. So now I can do this. Return num squared would be this. To do exponents in Python, it's 2 asterisks. So asterisk asterisk 2. That's gonna square this variable num. Okay, now some more experience. We've now changed the signature of our function such that it requires a formal parameter named num. If I try to run this function now by calling it like we did before, we'll get an error because Python will say, hey, you've created this function. It requires a parameter and you didn't supply one. So here I just ran it and you can see, what does it say? Traceback error. Okay, square is missing one required positional argument, num. Now, why does it call it an argument? Because down here where we made the mistake, when you call the function, what you put inside the parentheses is called an argument. When you define the function up here, this is called a formal parameter. So we were missing that argument. So now if I clear my shell and run this again, you'll see that I am getting 4 out below. So something to point out, we can't get to num outside of that function. You see right here, I've said num, and I told you num is a local variable inside of our function. If I try to print num, you notice I'm outdented. That means I'm not part of this code that's in that function. So if I try to access num outside of square, it's going to tell us it's not defined. So here we go. What does it say? Num is not defined. Okay? The old rule is if you create a variable inside of a function, either as a formal parameter, or if I create a variable inside of here, let's just call it result. Okay, so now what did I just do? Well, I created a formal parameter num. I said num squared, and I'm using the assignment operator to store the result in a variable called result. And now I'm returning result. Well, I can't get to result either. The old rule is what happens in Vegas stays in Vegas. And that's what happens inside this function, stays inside this function, unless you send it back with the return. Okay, so back to this again. Let's run that function. You can see that if I square 4 squared should be 16, right? Let's run it. There's our result, 16. Okay, so that's a function, creating a function and calling the function here. Okay, let's create another function and we'll make it a power function so that we could have 2 parameters that are passed to it. Right now we're only taking 1 in. You can see when we call the function, this 4 gets assigned to num, and we can use it inside the function, and then we send the result back with return. Okay, so let's change this and make it a power function. We want to take a number in and we want to raise it to some exponent. Okay, so right now you can see I have 2 formal parameters. Notice that I have to separate them with a comma. That's important. Okay, so now this function power expects 2 parameters. Down here where I'm calling it, right now I'm only providing 1, so if I try to run this, you'll see what happens. What's it say? Missing 1 required positional argument named exponent. So now if I wanted to raise 4 to the 4th power, okay, I'm supplying 2 arguments. When this is called, this 4 right here is going to be assigned to num, and this 4 is going to be assigned to exponent. So here, 4 to the 4th power, okay, is going to be some big number. Let's run it and see. It's 256. Okay, so this is how you could create a function and call it, similar to what's being done in your Project 4. Okay, now let's do some input. To get something from the person that's running the program, there is a function called input. So let's do this. Num string equals input. Enter a number to raise to a power. Okay, so what's this doing? When we run this program, this is going to show in the shell window. This is what's known as our prompt. This is going to show up down here in the shell window, and it's going to wait on us. Our program's going to wait for us to type something in. When we type something in, it's going to assign the result to num string. Now num string, the input function, always returns a string, which is, as far as Python's concerned, is something you can't do math with. Okay, it looks at a string as something with quotes around it. So in order for us to use that in math, we have to convert it. So we can do this. Number equals, if we want it to be whole number, this is our function to convert from a string to a whole number. Okay, so think about what I just did with these 2 lines. This line is going to ask somebody to key a number in that we want to raise to a power. This line is going to take whatever they keyed in, and it's going to run the int function against it. It's going to convert it to a number, and it's going to assign the result to this variable called number. And so I'm going to change that to be number. Okay. Now this will let us key anything in and raise it to the 4th power, but let's make this program a true calculator program. Power string equals input, enter the exponent. Okay, notice I have quotes around it. Same way as before. Let's do this. Exponent equals int power string. Okay, so following kind of the pattern that we did here, we're asking them to key the exponent in. We're capturing it, and let's just make that exponent. Okay, and we'll change it down here. Okay, so this is going to ask them to key the exponent in. It's going to store it in this variable exponent string. This is going to change the exponent string into an actual whole number using the int function. So now we have a whole number. And now we can replace that 4 with exponent. Okay, and so now we have a full-blown calculator program here that we can run. Here I am running it. You see the prompt down here. You'll see that the program is waiting on us. It's actually sitting on this line right here, waiting on us to key something in. So let's key 8 in. That's our number. And what power do we want to raise it to? Let's raise 8 to the third power. Okay, 8 to the third power is 512. Okay, so that's all I have to show you about functions. That's everything you need to know in order to do Project 4. So good luck with Project 4, and hope the video helped.